Implementing stack using an array. To implement the stack data structure using an array, we need an array of required size, which means the size of the array, the maximum number of elements the stack can hold, and also the variable which is called the top pointer, which would hold the address of topmost element in the stack to insert, to perform insertion and deletion from the stack. And by default the top would be equals to -1, which means null when the stack is completely empty. So here mainly we need two variables in the stack when we want to implement the stack using an array data structure. Two variables we will be using. One is top variable, another one is max variable. This top variable is used to hold the address of topmost element in the stack, and this max variable is nothing but the maximum number of elements the stack can hold, the stack can store. That is what the max variable is. While discussing the pseudocode for push and pop operation, insertion and deletion operation, you would understand the importance of these two variables, top and max. Now let us see the array representation of stack, how the representation of stack using an array data structure would look like. So this is an array representation of the stack. Both of this are here. I have shown this diagram shows the array representation of stack in horizontal manner and this in a vertical manner, because in the last example we discussed the stack like this only, in this structure only, right? Sorry. This is how the stack data structure was, right? In the previous example, the stack data structure would look like, and the elements can be placed like this, one on top of the another, 5, 10, 15, 20 like this, right? So this you just tilt this in a horizontal way. Since we are using an array data structure, this is how it would look like, right? And here if you check, as I discussed before, we need array of required size, right? Here if you check, the stack size is 10. Since we are using an array data structure, the array size is going to be 10, which means the array can hold up to maximum 10 elements here. And we have top variable, right? This top variable would be holding the address of topmost element in the stack. So if you check here, the topmost element in the stack is r. R is stored at the index position 5, so the top variable would be pointing the index 5. I am using one top variable which would be holding the address of the topmost variable, which means the top would be pointing the index position 5. Why? Because the index position 5 is holding the topmost variable, which is r. And this max variable indicates the maximum number of elements the stack can hold. So here max is, right now the maximum value is 10, which means the stack can hold 10 values into the stack. Let us see the operations now. When it comes to stack, it supports 3 basic operations: push, pop and peek. Let us discuss one by one. First is push operation. First operation. Push operation is used to insert an element into the stack. The new element is added at the topmost position of the stack. However, before inserting the value, we must check if top is equals to max -1. Why? Because when you want to perform the insertion, especially using an array data structure, we need to check for the availability first. Only if there is a space left, you will be able to perform an insertion. So you have to check for overflow condition, because when it is overflow, which means when there are no space left, you won't be able to perform insertion here. Let's write the pseudocode. I want to perform new element into the stack, so I have to check whether the very first step is I have to check whether the space is left or not. To check whether the space is left or not, the condition is going to be if the top is pointing max -1, which means if the top is pointing 9, here the max is 10 and the top variable is pointing the index position 5, right? Now you have to check whether the top is pointing max -1. Maximum here is 10, which means maximum 10 elements my stack can hold if the top pointer is pointing max -1. Max -1 is 9, which means if the top is pointing here, if the elements are, if the array is completely full, when the array is full, my top variable would be pointing the index position 9, right? So if the top is pointing max -1, which is 9, which means there are no space left in the array to insert a new data element, it has to print, since there are no space left, it has to print overflow. otherwise end if the top is not pointing max minus 1, yes, my top is not pointing max minus 1, it is just 5 only. Simply you have to set your top equals to top plus 1, which means increment the position of top. Now top was pointing 5, now after incrementing top would be pointing 6, top equal to top plus 1. Now the top variable pointing the index position 6. Set top equal to top plus 1, and in the place of top you can insert the value, whatever the value you want to insert. Value, for example, value 20 I want to insert into the stack. This, okay, it has character, right? Okay. Character, yes, I want to insert into the stack. So you can insert whatever the character you want to insert into the stack, that can be inserted. Now S would be inserted at the position of top. Top is pointing now the index position 6, initially it was pointing 5. After incrementing, my top is pointing at index position 6. At the index position 6 I am inserting a new character which is S, and end. This is how we are supposed to perform push operation. If you look at this pseudocode, this pseudocode is similar to array insertion at the end. Since this, in using the stack data structure, both the insertion and deletion can be performed through only one end, we can follow the pseudocode of array insertion at the end and array deletion at the end for a deletion operation. This is how we are supposed to perform push operation using a stack data structure, especially using the array implementation, using the array representation. And the second operation is pop operation. Let me write here. Second operation is pop operation. Pop operation is nothing but which is used to delete the topmost element from the stack. However, before deleting the value, we must first check if the top is equals to null. If the top is equal to null, which means the stack is completely empty, the deletion operation cannot be performed. When it comes to push operation, we checked whether the top is equal to max minus 1, and when it comes to pop operation, we checked whether the top is equals to null. Why? Because if the stack is full, we cannot perform the push operation, which means the insertion operation. When the stack is empty, we cannot perform the deletion operation. So the very first step under the pop operation we are supposed to check is if the top is equals to null. If the top is equals to null, which means if the top is completely empty, we have to print underflow. Why? Because when the stack is completely empty, deletion operation cannot be performed. So you have to check for underflow condition first when it comes to deletion. If you check, we'll take this example only, this example array structure only. Check your top whether your top is equals to null. No, my top is equals to 6. My top pointer is pointing variable 6. So it's not underflow condition, which means I am able to perform the deletion operation here in the current existing array structure. So check. Now you can perform the deletion. So character equals to means what? I want to fetch the value out of the stack, right? So you can perform whatever the element is placed at the top of the stack, whatever the character has been placed, the character S has been placed at the top of the stack, right? You can fetch the stack top element and store it under the stack, or if it is an integer value, you can store it under the value. So after fetching out the value, fetching the means what? We want to refer the value for some purposes, right? So deletion in the sense like you want to ignore the value from the array, right? So if you want to ignore directly, you cannot ignore directly, you cannot decrement the top position. First you fetch the value and store it under some other variable, and then you can decrement the top pointer. Now you can decrement the value top equals to top minus 1. So after executing this statement, the topmost element, which is S, right? The topmost element will be stored under, the topmost element is S. So S would stored under the character variable. After fetching the value yes and stored it under the character variable, now you can decrement the top equals to top minus 1, which means after executing this statement top equal to top minus 1, now my top variable would be pointing 5, which means variable the value the index position till 5 only would be considered. The values which are there till the index position 5 alone would be considered. Suppose if you want to insert a new value, the next as a next step, if you want to push any new value, that can be pushed into this new index position which is at 6. So this value would be replaced and new value can be written here. So now since I have reduced it, since my top variable pointing the index position 5, the element right from 0 till index position 5 alone would be considered into the stack data structure. Now the deletion has been done, you can end the pseudocode. This is how we are supposed to perform the deletion operation from the stack. And the third operation is peek operation. Peek is nothing but displaying the topmost element from the stack. This is simple. Again, when the stack is completely empty, you cannot display any element, right? When the stack is completely empty, this peek operation is mainly to return the value of topmost element of the stack without deleting it from the stack, just displaying the topmost element, returning the topmost element without deleting it from the stack. So however, the peek operation should first check again if the stack is empty, that is if the top is equals to null. If the top is equals to null, which means if the stack is completely empty, it has to print that the stack is completely empty. So the peek operation cannot be performed. Otherwise, if the stack is not empty, just it has to return the stack topmost element and end. So to display the topmost element without deleting it from the stack, if you check the current stack topmost element is R, right, it would return R, because at the place of top, at the stack top, the character R alone is there, so it would return the topmost element of the stack, and you can end the pseudocode. So this cannot be performed when the stack is completely empty. If the stack is not empty, you can return the topmost element of the stack. Thank you.